Hey, it's Mr. Like again. I'm here at Like Labs, and I'm thinking about all the questions that you guys had with this car and the ramp. One of the things that we looked at in that giant jump with the real car was the height in which they released it. Do you think it was important that they knew how high up in order to make it go? What does that change? What does the height change in the experiment? Well, does it change how fast the car is going at the bottom? Does it change then how far the car will go on the carpet? Well, this is an investigation we should probably think about. So today, we're going to set up an investigation that tries to figure out how the height affects the distance moved on the carpet. Now, these are two variables that we're going to look at today. We're going to look at the height, we're going to change the height, and then we're going to see how the distance changes. When you pick a variable that you want to change, for us it's the height, we call that an independent variable. An independent variable is a variable that we decide. It's a variable that we change. Now, the distance the car moves depends upon the height that it was dropped from. We call that a dependent variable. The dependent variable depends upon the independent. That's a lot of words. The independent variable then is the one that we change. The dependent variable is one that we see what happens. And hopefully, the dependent variable and the independent variable, both of them are related. And so we're going to see if changing the height of the ramp does affect the distance that it goes, and how much it affects it. If it affects it a little bit, not a big deal. But if it affects it a lot, that is a big deal. So we need to set up an experiment. What are some things that we need to keep in mind when we set up this experiment? First off, we have to remember the variables that we keep consistent. For me, it was the purple car, it was the green ramp, and it was the planetarium carpet. I wrote those down on my piece of paper here. We call those variables the control variables. Those are the ones we've controlled. We're not going to change those at all. Because if we change the type of car, then we don't know if it's going to be related to what we did yesterday. So we have to be sure that everything is the same. The only thing we can change in an experiment is one variable. We are going to change the height. And then we're going to see how the distance happens. Okay? So the height is the independent variable. The distance is the dependent variable, and I've got my controlled variables down here. I also kind of drew a little setup here on how I'm going to measure some things. I wrote down that I want to do 5 trials to make sure that we have a consistent number. Now, what do I mean when I do 5 trials? Well, let's say I drop it from 5 centimeters like I did yesterday. In order to figure out if that 5 centimeters was really good, like if my run was really good, I had to do it 5 times to see if it was consistent. So I'm going to need to drop it 5 times from 5 centimeters. And then maybe figure out what about is the average of those numbers. Then I'm going to move my ramp up to a higher height, maybe 7 centimeters or 8. Then I'm going to drop it again. How many times do you suppose I should drop it from 8? That's right. I should drop it 5 times from 8. And then I can figure out if my numbers are pretty consistent. How many different heights do you think we need in order to figure out how these two variables are related? That's how many different heights should we have? Well, in science, we're going to need at least 3, maybe even 5. And again, if I had a much bigger experiment, I would probably want to do a lot more. So today, you're going to drop your car from your 5 centimeters 5 times, figure out the average. Then you're going to change the height to 3 or 4, maybe 5 different heights and see how those variables work. Once you have your data, then we can start to analyze it. Have fun. And I'm going to make my own data in the planetarium. Okay, now that we've done our experiment and we have our data, it's time to analyze it to see if these two variables are related. If one of them goes up, does the other go up? If one of them goes up, does the other go down? If so, by how much? So I have my data table right here with my trials. I did 4. 1, 2, 3, 4. The heights that I chose with my books were 5, 7, 9, and 11. And the average distances for each height in 5, I did 5 of them at 5, and they all averaged around 40. I did 5 different trials at 7, and they kind of averaged around 44. And I did another one at 9, 5 of them at 9, and they did 50, and then 55 was the average, somewhere around 11 centimeters when I dropped it. So, in order to see if these variables are related and how they're related, scientists make a graph. So the graph that I have has 2 axes. It has what's called the y-axis, which is where we put the dependent variable, and the x-axis, where we put the independent variable. Now, the dependent variable that we had was the distance. Now, you'll remember that the distance in centimeters depended upon the height in which we were dropping it from. So I'm going to put the height in centimeters down here. Now, on my axes, I know that on the x-axis, the height, I have to get up to 11. So I'm going to start it at 0, and I'll just go like 1, 2, 3. Now I have my x-axis all labeled and ready to go. My y-axis, I have the average distance. That has to go up to 55. So I'm going to go by 5s. 5, 10, 55. So the first thing you should do is label your axes. Make sure they're in a way in which it goes all the way up to the top. Okay? Now we need to put our data points. So at a height of 5 centimeters, it did an average distance of 40. So my height was 5, so I'm going to go here, and I'm going to go all the way up to 40. And I'm going to put a dot, because that's a data point that I had. Then at 7, it went to 44. So 7, and there's 40. This is kind of 42 and a half. 44 is just shy of 45. So I'm going to put a dot right there. Now look at those dots. Does it look like when the height goes up, so does the speed or the distance that it moves at the bottom? One of the things that scientists do is they draw a trend line, because you got to remember that these points aren't perfect. You know, some of the trials were above or below each of these points. So these are kind of the average. So a scientist would draw a trend line. A trend line, and I can use this, is just a straight line that kind of meets all of the data points. Kind of looks like that. So we can see that these are definitely related. The higher the track is, the longer the distance is that the car is going to move, which means it's going faster at the bottom. This is my experiment. Can you handle your experiment using your data? Make a graph and a data table of all your data. Okay, now that we finished our experiment, it's time to make a claim. A claim is what we think the relationship is between those two variables. As you increased the height, did the car go farther? Can you make a claim that that is true? Well, every claim that we have, any claim that scientists make, has to be based on evidence. Lucky for us, we just took a whole bunch. I know in my experiment, I can very solidly make a claim that as you increased the height of the ramp, the car tended to go faster at the bottom, and thus it went farther on the carpet. What claim can you make? At the bottom of your sheet, make a claim about how those two variables are related. Then you can turn it into your teacher. I can't wait to see how you guys did. Next time we're going to come back and look at some other variables that you guys came up with in your questions about that car jump. I know you came up with lots of different things that I didn't even think of, but I think there's some in there that we can probably investigate. Once we're done, we're going to be able to make claims about all the different variables, Which ones are important? How important are they? And which ones do we have to that we can kind of ignore because they're not as important? So making claims is really the one of the most important parts of science. And remember, all of our claims are going to be based on investigations that we do where we gather evidence. Gathering evidence to make claims and figure out the world is a great way to learn science. I know that's why I like science.